We haven't had this course yet, but I want to remind you that we do have a test tomorrow, and that test is going to have a big problem on it, not unlike the one that you're going to see in your homework tonight. And so today in class we talked about the problem-solving routine, and so this homework is going to kind of walk us through that problem-solving routine, and it's going to take us through step by step of how to analyze this problem and try to do a good job of answering it. So that you can use that routine tomorrow, and then eventually later on in our course you can use it without being guided through it in this way. So let's go ahead and dig into this. Miss Francis is planning a birthday party for her daughter. There will be 22 children at the party. In order to seat them all, she needs to rent square card tables. Only one child can sit at each side of a card table. And so far I've noticed some information that might be important, so I'm going to start doing a little highlighting. I see 22 and one child per table, one child per side of a table. Each Miss Francis wants to arrange the tables in a rectangular shape so they look like one large table. The room is large enough that a rectangle can be made with more than that. The room is large enough that the rectangle can be made with more than one row of tables. Okay, so we have several things we got to deal with here. Let's go ahead and just go through each of the questions we're asked. How many different arrangements can Miss Francis make to seat all 22 children? What is the smallest number of tables that Miss Francis needs to rent? Directions to solve the problem. Apply the steps of the mathematical problem-solving routine. Okay, so we have a job here, which is to make sure that we think of all of them, all of the different ways in which we can solve the problem. So let's try to visualize a situation. Consider drawing a diagram. So we're just trying to understand the problem. And so what we're thinking about is that there's 22 kids, and we have card tables. Kids can sit at each side. But something that we should think about is that if there's two card tables right next to each other, that kids can't sit at the side where they meet, or they would be sitting inside the table. So anytime two card tables like meet together, even like in an arrangement like this, it means that it's gonna mean that that card table can't sit four people, but like say like this one here, because it's on a corner, can only sit two people. And then there's going to be situations where maybe a card table only sits one person because it's surrounded by other card tables. Okay. Let's state the problem in our own words. I'm going to try it like this. I'm going to reread a little bit first. Miss Francis is planning a birthday party for her daughter. There will be 22 children at the party. In order to seat them all, she needs to rent square card tables. Only one child can sit at each side of the card table. All right. I'm going to write it like this. Arrange square card tables so that 22 kids can come to the party. All right, so that's what I think is kind of going on, and we're going to have to do some experimentation. What is the important information in the problem? Well, there's 22 kids, one kid per side of the card table. And card tables are square. Okay, so let's think about strategies. We're just coming up with a plan now, so I feel like we have a pretty good understanding of what the problem's kind of asking us now. Now that we know the aspects of it, let's come up with a plan. And I'm trying to think through this, and I can't think of a way to just do it mathematically. Pretty much what I feel like I'm limited to is visualizing it. Visualize the arrangements. And so that's going to be draw a picture. And hopefully that makes sense to you too, because I just can't see a mathematical way of doing the problem other than to diagram it, which is a mathematical skill. Um, Predict an answer. So we have two different answers, or two different questions. There's question A, how many different arrangements can Miss Francis make to seat all the children? I think I'm just making a prediction. You could make like squares and you could make rectangles. I bet there's like at least 5 ways to seat 22. And then let's look at the second question here. B, what's the smallest number of tables Miss Francis needs to rent? I'm just totally guessing here because sometimes a prediction is just a guess. I'm trying to like visualize it. I think since you have to have 22, I'm going to guess like, I don't know, 10 tables. I think it's going to be like some kind of arrangement like that. But I might be wrong. I'm making a prediction at this point, and we'll see how close my prediction is. All right, so execute your plan. So we've got this grid, so you can tell that the people that wrote this problem are thinking, hey, I bet they're going to visualize this with a diagram. And so that's, I think, exactly what we should do. I'm going to draw in this wonderful purple color. So we need to come up with arrangements that are rectangles or squares that are solid blocks of tables, solid blocks of these card tables, so that 22 people can sit. And so the first thing I can think of is just like one super long row of tables. So one, two, I'm going to zoom in here. So there's one table, and so we'll have 1, 2, whoops, 2, 3 people, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So there's one arrangement. I'm going to try to describe it. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tables. 10 tables in a row. So that's one arrangement. And so I'm trying to think back to that organization stuff that we talked about, trying to organize our answers. And I remember when we were doing the coins problem, I believe it was Skylar suggested we do something like sequentially. So that's one row of tables. I think the next natural thing is to see if we can do this with 2 rows of tables. I'm just going to switch colors because I can. Alright, so let's make 2 rows of tables, and we'll continue to proceed this way. And so I've got 1, 2, 3, 4 kids. And then I make a second column, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So that's 2 rows of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. 2 rows of 9 seats, 22 kids. And so I'm noticing a pattern. One row was 10 tables in a row. 2 rows was 9 tables in a row. I think maybe 3 rows, when we do this one, is going to be 8 tables in a row. I'm just predicting. This is something called monitoring my progress. I'm trying to think through what we're doing as we do it. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, whoops, put a kid in the table. 17, 18, 19, 20, 21, 22. And it looks like it's 3 rows of 8. Noticing a pattern here. Okay, let's keep going. So we're just answering the first question right now, which is how many different arrangements could she have? My prediction, I think, was 5, and we've got 3 so far. So let's see what we can do. So we tried 3, a row of 3. Let's try a row of 4. We'll do it in dark blue. So row of 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, good morning, 17, 18, 19, 20, 21, 22. Alright, so that looks like 1, 2, 3, 4, 5, 6, 7, 7 rows of 4. And let's try again. We'll try it in brown ink this time, or digital ink, I guess. So because I've noticed this pattern, it's 10 tables in a row, 2 rows of 9, 3 rows of 8, 7 rows of 4. I think the next one is probably going to be 5 by 6. So I'm going to make my 1, 2, 3, 4, 5. I predict that it's going to be 1, 2, 3, 4, 5, 6. Just because of this pattern, every time I add a row of tables, it seems like it's reducing the number of columns that I have to make. So I'm just going to test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I was totally right. I love being right. Just draw in all the tables here. And so that is 6 rows of 5. And so I'm thinking through this. If now I try to do rows of 6, so 1, 2, 3, 4, 5, 6, I'm only going to have to go over 1, 2, 3, 4, 5. And if you look at this, it's exactly the same shape as we just made. So I think we found all the answers at this point. And the reason we can be sure is that if we keep on putting on new rows, the number of columns is going to go down. And so if you look at it here, we have 10 in a single row. So there's a 1, a 2, a 3. Here, I'll highlight for us. We have a 1 here, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, and a 10. So we've counted 1 to 10. So it seems like we've covered all of the possibilities at this point. Oops. So given that we've covered all of the possibilities, and I erased that and then backed up, it seems like we've covered question A. So question A was how many arrangements are there? 5 possible arrangements. And then let's answer question B. So if you recall, question B was, what is the smallest number of tables that Miss Francis needs to rent? So here we have 10 tables. I'm going to make notations in this, how about a pink color? So this arrangement has 10 tables, just counting them. And this arrangement has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 tables, which, if you're counting tables, you could also do 2 times 9 to get 18. And so I'm going to do 3 times 8 is 24 tables. 7 times 4 is 28 tables. And 6 times 5 is 30 tables. And so it seems like as we move away, as we add rows, as we make bigger blocks, that you end up with more tables, and one of the reasons, I'm going to do a little highlighting here, is that you end up with a bunch of these not so useful tables in the center. These tables, there's nobody sitting at, but she's paying for, so it wouldn't be very useful. And then there's also all of these sides that people can't sit at in the center. And so the answer to A was 5 possible arrangements, and the answer to B is she could rent just 10 tables. Which it seems like both of my predictions, even though they were guesses, were right. So what can we learn from this problem? What strategy did you use, and why did it work for this problem? For what type of problem would this strategy work in general? So this is the part where we actually grow, like we not only grow some dendrites because we tried, but we try to increase the likelihood that we remember by reflecting on it. So looking back, we can learn that diagrams are helpful. It's good to remember area formulas. Those were helpful. And I'm going to write also proceed in sequence. That was really helpful to us. And I think of the things that will work generally, the one that will work most generally is this proceed in sequence thing. And diagrams will be helpful in the future too, but organizing our work is really helpful. And so I think in class we told you to skip number 7 because we're not using that personal record sheet. So that's the homework for tonight. We'll see you in class tomorrow.